Right then, welcome to my video. So here I'm gonna start with continuation of the first video. So if you haven't watched that video, make sure that you watch it before you watch this one. So remember, last time we talked about the average rate of change, and we also talked about the instantaneous rate of change. So here, these are the examples of continuation of instantaneous rate of change, okay? So now after these examples, I'll most definitely move to other sub-concept here under calculus, which is called derivative of a function. So now let us try to solve these questions. Let us go. So now they say to us, find the gradient of f at a given point and the equation of the tangent to y is equals to f of x at that given point. So now what we are looking for here is we are most definitely looking for, let me highlight, we want to determine the gradient of f at the given point. So we want to determine the gradient, and then we also want to determine the equation of the tangent. Now, this is what is happening from the instantaneous rate of change. Quick reminder or a quick recap. Remember, I said to you, instantaneous rate of change. It is given by which formula? And then I told you that instantaneous rate of change, what does it mean? It means a gradient of a tangent on a curve at any point, okay? So in order for me to remind you of what is instantaneous rate of change, let us try to solve this question and see maybe if you understand. So 1.1, we are given a parabolic function, and we know that parabola is a curve. It is a curve. So now let me assume that our parabolic function, which is a matter graph, is gonna look like this most definitely. Just that I'm not gonna draw it on a Cartesian plane. So our parabolic function will look like this, which is this. Okay. Now let's assume that this point, which is 3:9, I will assume maybe it is somewhere else over here. So I will say this is 3.9. Okay, so this is graph of f, and this is a point whereby graph of f passes through. So remember what I said to you. I said for you to determine the gradient of a tangent or a gradient of a linear function, you always need 2 points. And I said at some point there is a point whereby on the first video there is a point whereby you're only going to need only 1 point to determine the gradient, which is in this case where we do instantaneous rate of change. So now at this point, say at this point, there is most definitely a tangent passing through this point. Remember what is a tangent? Tangent, it is a linear function that passes through a curve only at one point. This doesn't even look like a tangent. Let me try to fix it first. Okay. Okay. All right. So let's say here is our tangent. Not gonna be perfect, but I'll try. Okay, here will be our tangent. So now what we are basically looking for, we are most definitely looking for the gradient of the tangent. We are also looking for the equation of this tangent. Most definitely it's a linear function in a form of y is equals to mx plus c. So firstly, let us try to determine the gradient first before we can determine the equation. Okay, so now how are we going to do that? To determine the gradient, we're going to use instantaneous rate of change. How so? First of all, I'm sure you have an idea what formula are we going to use, but I'll just start here. I'm going to determine f of x plus h, which is given by, so where I see x from this, on this function, I'm going to substitute x plus h. So here I'm going to have x plus h to the power of 2. And therefore, let me try to expand the following equation. So here I'm going to have x squared, I'm going to have 2xh, and I'm going to have h squared, okay? And therefore, I know that f of x is equals to x squared. Therefore, I'm going to use that equation that says to determine the gradient of a tangent at any point on this curve, I'm going to say limit of f of x plus h subtract f of x divided by h as h tends to approach 0. Therefore, I'm going to say limit. This is a formula that we are going to use to determine the gradient of a tangent. So limit h tends to approach 0. Now I'm going to substitute f at x plus h, which is x squared plus 2xh plus h squared. Subtract from the formula. Now I'm going to use x squared divided by h. Now limit as x tends to approach 0. Now this and this falls off, and then I left with 2xh plus h squared. But already, I'm gonna take out the common factor out of these two terms. So my common factor is h, and then here I left with 2x, and there I left with only 1h. Divide by h. Now I'm going to cancel this h with this h, and therefore immediately when I do my direct substitution, now I eliminate this. So I'm going to say 2x plus, I substitute my h to be 0, therefore gradient will be 2x. So that means gradient of a tangent in terms of x will be 2x. So that means if I have a point here, or I have a point here, or I have a point here, anywhere on this curve, if I want to determine the gradient of tangent at any point, maybe the point at here, let's say we have a tangent and then we have a point. If I want to determine the gradient of this tangent, I'm going to use x value of this point, whereby it is a point of contact between graph of f and its tangent. So if I have a point here, I'm going to get most definitely different tangent, different magnitude of a gradient of a tangent, but the magnitude of this gradient, I'm going to get it based on this point. So now for a fact that we're only given this point, which is 3:9, and then I have already determined the gradient of this tangent in terms of x. So this tangent passes through this point whereby the value of x is equals to 3. So what am I going to do? I'm going to say, oh, okay, so my gradient of my tangent will be equals to 2, whereby my x at that point is positive 3. I'm going to deal only with x value is positive 3. And therefore, when I multiply this, I get 6, which is my gradient of this tangent. And therefore, after determining the gradient of a tangent, I'm going to say y is equals to, now I know the gradient is 6x plus c. Therefore, I'm going to say this linear function, which is tangent, it passes through that point, which is given by 3:9. Therefore, I'm going to determine the value of c, which is my y-intercept. Now, what is the value of 9? What is the value of y? It's most definitely 9 is equals to 6x. Sorry, so what is the value of x is 3 plus c. And therefore here I'm going to have 9, and therefore what is 9 multiplied by 6? Let me do it. It's 6 multiplied by 9 is going to be 18. It's going to be 18 plus c. And therefore, I'm going to transpose 18 to the other side of the equation. It's most definitely going to be negative 18, but negative is going to be negative 9. C is 9. Therefore, the equation will be denoted by this. Y is equals to my gradient 6x, and then my y-intercept is negative 9. So this is the equation of the tangent, and this, it is the gradient of the tangent. But already we have indicated that the gradient of the tangent is equals to 6. Okay, so that's how we'll be solving 1.1. Hope it's making sense. Now let us move to Let us move to 1.2. So 1.2, it's almost the same thing, just that here we are talking about the hyperbolic function. Okay, this is also a meta graph of a hyperbolic function where both asymptotes are 0. We know hyperbolic function has y and x asymptotes. So here it's a meta function. So now let us try to determine the gradient. Remember the gradient of a tangent on a curve and the equation of that tangent. So what are we going to do? So to solve question number 1.2, we're most definitely going to say, I'm going to determine f at x plus h. It's going to be equals to 1 over, remember where I see x, I plug x plus h. So this is my basically equation. Now I'm going to determine the gradient. Now I'm going to determine the gradient of a tangent at that point. So I'm going to say a limit as h tends to approach 0, f of x plus h, subtract f of x, divide by h. Now I continue with my equation. I'm going to say limit as h tends to approach 0. Now what is f of x plus h? Now f of x plus h is 1 over x plus h, okay? Subtract, what is f of x? F of x is most definitely 1 over x, okay? F of x is 1 over x, it's 1 over x. Now, I don't like doing beggar, so this is what I like to do. If this division line, I'm gonna write it over here, divide by h, okay? Divide by h. This division line is presented by this division sign. I don't want to do complication. I don't want to complicate my stuff here. So now a limit as h tends to approach 0. So now on this fraction, this is what I'm going to do. I'm going to add these two fractions together, but by multiplying both by the denominator. So this multiply 1 multiplied by x is going to be x. Sorry about that. Sorry. And therefore, I'm going to say x plus h multiplied by -1. It's -1 multiplied by x plus h. Divide by the denominator multiplied by the denominator is going to be x multiplied by x plus h. And therefore now this is what I'm going to do with my division sign. I'm going to change it into multiplication, whereby I'm going to take the reciprocal of this, which is 1 over h, okay? Right. Therefore here I'm going to say I have a limit as h tends to approach 0. So here I'm going to have x, this multiplied by that is -x, this multiplied by that, it is most definitely -h, divide by x plus h multiplied by 1 over h, okay? So now let me continue over here. Let me take this over here. So now I'm going to say is equals to limit as h tends to approach, I love x, as h tends to approach 0, this and this, they're gonna fall off. I left with -h at the on top there, and therefore here I have x plus h, close my bracket, multiply by 1 over h, okay? Now this h is going to cancel with that h. I'm gonna left with -1 multiplied by 1, it's most definitely gonna be -1 over, now I do my direct substitution. I'm gonna substitute 0 there, and then I eliminate that. So I'm gonna say x plus 0, and then close my bracket, is equals to -1 over x squared. Now this, it is the gradient. This is the gradient of a tangent at any point of this curve, which is hyperbolic function. Remember, hyperbolic function, it is also a curvaceous function, okay? Let me just write here and here. Let me eliminate this and this. This is also a curve, okay? So now, this is what I'm going to do. I'm going to determine the gradient of this tangent, whereby x is equals to 1. So we're going to say gradient, once more again, is equals to -1 over, what is the value of x? It's +1 to the power of 2, and therefore our final answer will be -1. This will be the gradient of tangent whereby x is equals to +1. Now, after determining the gradient, we're going to determine the equation of the tangent, okay? So we're going to say y is equals to mx plus c. Y is equals to, our gradient in this case is -1, x plus c. And then we're going to say this graph passes whereby x is equals to +1. Therefore, we're going to say y is equals to negative, our x is +1 plus c. I forgot to say, yes, right? Okay, it's fine. So now here we have y is equals to -1 plus c. We need to solve for value of c. But now this is what is happening. Remember, we're not given the complete coordinates whereby x is equals to 1. So to determine the value of y, we can also utilize this graph, okay? Because the point of contact, this graph does also passes here, whereby x is equals to 1. So from the given information, let us determine y that corresponds with this x value. So we're going to determine f at 1, which is equals to 1 over 1. And therefore, our y will also be 1, okay? F at 1 will be something like this. And therefore, our coordinates will be 1:1, okay? So our y value is going to be 1, which is equals to -1 plus c. And therefore, I transpose 1 to other side of the equation. Therefore, the value of c is equals to 2. Now, let's conclude. Our equation is going to be y is equals to -x plus 2. Therefore, it is the equation of the tangent that we were supposed to determine, okay? All right, then let us continue. Well, now, what you see here, it is a derivative of a function, okay? So now a derivative of a function is basically what we have talked about. But let me take you through the whole summary so that you can understand what is this actually derivative of a function, okay? So now the derivative of a function is usually denoted by this notation, okay? By this notation, f prime x. It's f prime x, prime x, okay? So this is a prime. So this prime, it is called derivative, okay? First derivative, it's 1 prime. If we have 2 primes over here, that's second derivative, okay? That's how we see a number of derivatives of a function. So it is usually denoted by this. So it may also be denoted by this, okay? First derivative or derivative of a function, dx of f of x, okay? Dx, we derive in respect to x. Dx of f of x, also, this is one of the notations that we can use to show that we are talking about a derivative of a function, which is function f of x. Again, we can also denote our derivative of a function in this form, d over the dx, okay? D over the dx, this is another notation that we can use, or another notation that we can use, the d of f of x over dx, this is another notation, or we can use dy dy of over the d of x. We can also use this notation if only y is equals to f of x, most definitely if y is equals to f of x, okay? These are the notations that we can use to represent our derivative of a function. So now, what is derivative of a function? Now, derivative of a function, it is a gradient. I've already talked about this, and I'm not going to say it multiple times, but I'm just going to say it for now, which is for the last time. Derivative of a function, it is denoted by this formula. So now you can understand by just looking at this formula that what is a derivative of a function? Derivative of a function, it is a gradient of a tangent of a curve at any point. Okay, so that means derivative of a function, it is a gradient of a tangent on a curve at any point. So now this formula, it is normally called, it is what we call the first principle. Okay, so remember we have talked about average rate of change, whereby this limit it is not there, and then we talked about the instantaneous rate of change, whereby we introduce this limit. Now we're talking about the first principle. It is the instantaneous rate of change. Okay, first principle, but just that we denote by derivative notation, whereby first derivative of x will be given by this formula. Okay. Now, the process of finding a derivative is called differentiation. Now we are going to differentiate. So if you want to determine the gradient of a tangent at any point, just know that you are differentiating. Okay, so now let's have a look at these examples. So now example number 1, it says to us, determine the derivatives. When you determine the derivatives, what are you performing? You are performing differentiation. So we want to do differentiation of this function. So determine the derivatives of the following functions from first principle. Okay, because there are certain way to determine the derivatives, but because I will do that later on. Okay, I'll show you on the other video how to determine the derivative using the rules. Okay, so now we're just going to use the first principle to determine the derivative. So let us start with first function, which is negative 2x squared. So 1.1, we have f of x, which is equals to negative 2x squared. Let me confirm. Yeah, I'm sorry about that. So we're going to determine that's the derivative of this function using first principle. And do not forget that this is the formula that we're going to use for first principle. Okay. So now, firstly, we're going to determine f of x plus h. F of x plus h is equals to negative 2, whereby cx x plus h to the power of 2. And therefore, x to the power of 2 is x squared. This multiply by that, it's 2xh. This to the power of 2 is h squared. And therefore, we have negative 2x squared. We have negative 10xh. We have negative 2h squared. And therefore, this is f of x plus h. Okay? Now, let us determine derivative using first principle formula. So you're going to say first derivative of this function is equals to limit as h tends to approach 0. Now remember, here on top we have f at x plus h, subtract f at x, divide by h. Limit as h tends to approach 0. Now what is f at x plus h? It's negative 2x squared minus 10x h minus 2h squared. Subtract what is f of x. This negative is going to multiply with this negative. It's going to be positive 2x squared. Divide by h. Now this and this, they're going to fall off, and therefore I left with these two terms. So limit as h tends to approach 0. I'm going to take h as a common factor already. So I'm going to left with negative 10x. And then here I'm going to left with negative 2h divide by h. Therefore, this and this cancel or falls off. Now I'm going to substitute my 0 there. So I'm going to have negative x minus 2 times 0. Therefore, I was supposed to write it there. First derivative of this, therefore, this my solution is equals to negative 10x. Therefore, this will be my final answer. Okay? All right. So let us do another example, okay, which is example number, I think it's 2. Yes, example number 2, f at x is equals to 5. Now 1.2, we have f at x is equals to 5. So we want derivative of this function. So now this is what I want you to know. Each and every time when you determine or you want the limit of this function, okay, using first principle will always be 0 because a limit of a constant will always be a constant, okay? So I'll just say the first derivative of this will be equals to 0 since f of x is given by a constant number only, no variables such as x attached to this because we want to derive in respect to x. So there is no variable of x here, okay? Right. And therefore, we move into another question, which is question number 1.3, which is this one. F of x is equals to -3 over x. So this is most definitely 1.3. So remember, we are going to determine f at x plus h first, which is equals to -3 over x plus h. Okay, remember this one, I'm just going to write it in this way. And therefore, first derivative of the function is equals to limit as h tends to approach 0, f of x plus h subtract f of x divide by h. Okay. Now limit as h tends to approach 0. Now what is f of x? So f of x is f of x plus h is -3 over x plus h subtract what is f of x. F of x is -3 over it's -3 over over x. So this negative is going to be affected by this negative, so it's going to be +3 over x. Now this division line, I'm going to write it over here, divide by h. And therefore, limit as h tends to approach 0, so I'm going to multiply this by the denominator. So -3 multiplied by x is going to be -3x. +3 multiplied by x. Sorry about that. It's going to be +3x. +3 multiplied by h is going to be +3h divided by x multiplied by x plus h. And then this division sign, I'm going to turn it into multiplication and take the reciprocal. And therefore, this and this is going to fall off. H will cancel h, and then I do my direct substitution. So on top there, I will be left with 3 because 3 multiplied by 1 is going to be 3. So here I'm going to have 3 over x plus 0, where I did my substitution. Therefore, answer is going to be 3 over x squared. Therefore, this will be my first derivative using first principle. Okay. Therefore, that will be number 1.3. Now, let us do the last question. Let us do the last question. The last question, which is number 2, it says, find first derivative at 2 if f at x is equals to this. Use first principle. Okay. So remember, let me erase. So now we want to find first derivative at 2, okay? If f of x is equals to 4x to the power of 3 subtract x to the power of 4 divided by 2x squared. Let me confirm. And we're going to use first principle. So this is what I'm going to do. This equation can be simplified further. We're going to start by factorizing above bracket and then cancel the values that are, or the variables that are going to be able to cancel off. So from this function, I'm going to say f of x is equals to, I'm going to take x to the power of 2 as a common factor out of this bracket. So I'm going to left with 4 multiplied by x. And then here I'm going to left with negative x to the power of 2 divide by 2 to power, divide by 2 multiplied by x to power 2. And therefore x squared cancels x squared. Therefore, my function that I'm going to work with will be 4x subtract x squared over 2. Okay, so now let's work with this function to determine first derivative at 2. Now I'm going to determine f at x plus h, most definitely. So where I see x, I'm going to substitute x plus h, okay? So I'm going to have 4x plus h subtract x plus h to the power of 2 divide by 2, okay? And therefore, I have f at x plus h, which is equals to, so here I'm going to have 4x plus 4h minus into x squared plus 2xh plus h squared, close bracket, expanding this bracket over there, divide by 2, okay? Therefore, we're going to say 4x plus 4h, we're going to multiply with this negative x squared minus 2xh minus h squared, divide by 2, okay? And therefore, do we have the like terms over here? No, we do not have the like terms, so we're just going to left our graph as it is. And therefore, we are going to determine first principle using, we're going to determine first derivative using first principle. So here we have limit as h tends to approach 0. We have f of x plus h subtract f of x divide by h, okay? So let us do substitution, a limit as h tends to approach 0. Now, what is f at x plus h? This is the equation. So we're going to substitute this. So here we have 4x plus 4h subtract x squared minus 2xh minus h squared divide by 2 subtract f of x, in this case, f of, where is it? Here. We're going to take this one, the simplified one. So f of x is equals to how much? It's 4 minus x squared. Sorry, I left x here. It's 4x minus x squared divided by 2. And therefore, this division, I'm going to write it here, divide by h. Okay, I hope it's not confusing. So be careful. So when doing calculations or performing calculation, make sure that you are careful, okay? So that you do not do mistakes. So now limit as h tends to approach 0. Now let us multiply by the denominator. We are most definitely going to say, here we have 4x Oh, let me just multiply already by 2, okay, to avoid, okay, the thing is, the thing about this function is that the LCD is the same, okay? So that means we don't have to multiply, okay? Because now I see it's not in terms of X. So that means, let me just erase this. Right. So we're just gonna add because the denominator are the same. So we're just gonna add on top, okay? So now remember here we have negative. So that means this sign is gonna be positive. This is supposed to be positive. Remember, here we have this function. Wait, we have this function. So we have negative from the formula. So this and this is gonna be negative, and this is gonna be positive, most definitely. And therefore this and this, they're gonna fall off. This and this, that's also going to fall off, and therefore we left with 4h 2 and negative 2xh and negative h squared. So I'm going to take common factor already, so I'm going to take h as my common factor, and then here I'm going to left with 4, and then there I'm going to left with negative 2x and here I'm going to left with only 1h. Divide by these 2, which is common, and therefore multiply by 1 over h. Remember, I changed my division into multiplication and I take the reciprocal. And therefore this h will cancel this h. Therefore, we're going to substitute 0 over there. So we have 4 subtract 2x minus 0 divided by 2. So now, first derivative from first principle is going to be equals to how much? 4 minus 2x over 2. So meaning this is the first, this is the derivative, okay? This is the derivative of this function of f of x in terms of x. But they wanted us to determine first derivative at 2, okay? So we're going to take the very same formula, just going to continue over here. So we want to determine first derivative at 2, which is equals to, we're just going to substitute 2 wherever we see x. So 4 subtract 2, multiply by 2, divide by 2. So therefore, what will be the final answer? It's going to be 2 multiplied by 2. It's going to be 4. It's going to be 0. Okay, it's going to be 0 at this. It's going to be equals to 0. Okay, so meaning this is a tangent. This is a tangent. This will be a tangent of it will be a gradient of a tangent at any point. For a fact that it's 0 here, you will see as time goes by, when the tangent of a gradient is equals to 0, we are talking about the minimum or maximum stationary point or the turning points. So I hope this session was making sense to you. Thank you for watching and goodbye.